normal curve. Your test statistic instead of your z-test or your t-test is your p-hat test. So we're using your z-score. We're getting a z-score. We're taking your p-hat. This is from your sample. Instead of doing this, for z, this was from your sample. This was from your population. We're doing the same thing with your proportion. So sample minus population proportion, and we divide it by P times Q divided by N. The N is how many in your sample. Okay, so there's your, instead of making a standard deviation, we're going to do it this way. Yes. Okay. This whole part down here goes underneath that square root sign. And in your calculator, you're going to need parentheses around the numerator, just like you would for your z-score. There's also a test in your calculator. If you go to stat, it's one proportion z-test. Instead of using z-test, t-test, it's got your z-test. It's just one proportion z-test. So those of you that like the calculator will find this handy as well. It returns you a z-score and it returns you a p-value. The rest of it's going to work exactly like your z-scores do. So it's really not that bad to go through. Again, we state your claim. We do the same thing every time. We find the claim. We identify the HO, the null, the HA, the alternate. We find your level of significance. We do a sketch. Is it a right tail, a left tail, a two tail? We find your critical values, your cutoffs. We use your table 4. Use your level of significance, find your cutoffs, shade in your reject regions. Your reject regions are the small ones. That's the largest, the smallest allowable type 1 error we allow. We find your test statistic, and then we do a decision based on either your test statistic where it falls or your p-val. You can put your p-val in here as well. You can test with your p-val. We make your decision and we interpret your results. We do this, we follow the same exact format as we do. This is really, really close to your z-score one. Alright, so let's try one. We'll walk this one through. So if you look at page 375, it says, a medical researcher claims, and I only think we only have like 2 examples here. A medical researcher claims that less than 20%, 20% is a percent, but we build it into a proportion, of adults in the U.S. are allergic to a medication. In your random sample, here's your sample information. 100 adults, there's your N. 15%, there's your p-hat, say that they have such an allergy. At a level of significance of 0.01, is there enough evidence to support the researcher's claim? So when we use the word support, do we know our claim to be HA or HL? HA. This all kind of still fits together. Now here's this claim. Because we're using percent proportion, we use the P. P is less than, turn this into a decimal. Just move it 2 places to the left or divide it by 100, whatever you need to do. P is less than 20%. This is our claim. Without the equal sign, this is our HA. And yup, we use the word support when our claim is HA. All this has to fit in. The HO, which is your complement case, is greater than or equal to 120. What tail test is this? Left. It goes by the HA. So we've got a left tail test. This is our reject H0. Gotta say H0. This is our fail to reject H0. The reject H0 is small. That's your type 1 error. So it's got to be a small error. Now, we need to find your critical value. Is this critical value going to be positive or negative? Negative. So that we need to remember too. Anybody remember how you find your critical value, your cutoff? Table, inverse norm, and what are you going to put in there? Good. You only have one tail. You only have one tail, so we don't have to cut it in half. So 0.01, you're going to do your inverse norm, 0.01, and you're going to find your cutoff. Now remember, if it's on the right-hand side and you look up 0.01, you're still going to get a negative number. The right-hand side would be positive. The left-hand side would be negative. Normally, on the right-hand side, you do the 1 minus, but you don't have to do that. You can use the symmetry of your chart to do that. So what's your cutoff point? Okay, thank you. So if we make anything to the left of this, we reject the null. Anything to the right of this, we fail to reject the null. So we do your z-score. Your p hat, this is from your sample, minus your population proportion over the square root of p times q divided by n, sorry. Now, p times q is from your population, not your sample. So if this is your p, what's your q? 0.8. Okay, so remember that's from your population. So we're going to use that information and we're going to plug it in. And if you want, we'll use your calculator in a second. So your sample says 0.15. And remember your numbers here are all decimals in here. So you're doing your 0.20 times 0.80 divided by 100. Put the whole thing in your calculator, just watch parentheses in the numerator. But that's probably the only place you need your parentheses. And it comes out to be negative 1.25. You can also use stat, test, 1 proportion, z test. There's no t-test for a proportion, so it's only a proportion z-test. So we come here and we place it, and it falls right here, somewhere in here. So our decision is fail to reject H0. If we fail to reject this guy, we have to go along with this, so we cannot support your claim. So follow your chart. If your claim is your HA, and you fail to reject the HO, there is not enough evidence to support your claim that the mean proportion of adults allergic to medication is less than 20%. Okay? You fail to reject H0. You're good with this? Works the same exact way. Same exact way.
If you're put the calculator, what is x?
Oh, x, you have to use your x and your n. So this is part of your sample. So if you have 100 and you have 15% of 100, you have to do this. 15% of 100. That's your x. Remember, they build your proportion for you. And when it comes back, you get a p hat, and that'll show you your 0.15. Then you get a p for p-value. And remember, you cannot put a decimal in there because these are discrete numbers. So if you should multiply, say the percentage was, we'll say it was out of 98 people instead of 100, you would have to make sure you don't use a decimal point.
Just for p hat though?
Just for your p, yeah, for your x, yes. Because you can't have a decimal as a person or a discrete value. It has to be a whole number.
Okay.
Did you already put it in? What'd you get for your p-value?
5.056.
Okay, remember where this p-val comes from? Where does your p-val come from besides your calculator? If I'm going to test the p-val against the level of significance, we couldn't do this on your t-test, but we did it on your z-test. How did we get that value, that p-val? The area, good. The area of your z-score. So you went to your table and you looked up negative 1.25 and you found this area. That's your p-value, your probability value, your area under the curve. So we tested your p-value against your level of significance. You can still do the same test here. And your level of significance, fill it in. This is greater than, so therefore, fail to reject H0. P-value? We took this one off your calculator, but this is your z-score for your test statistic. We look it up in your table, for your z-table, and we look up negative 1.25, and that's its area. So that's the area to the left. Technically, that's this area right here. That's saying, well, that area is more than this, so therefore fail to reject H0. You can almost see it better when you look at your graph. Okay? Questions? All right. Try it yourself one. Try it yourself, number one. So, a researcher claims that less than 30% of adults in the U.S. are allergic to trees, weeds, flowers, and grasses. Is this the claim? How do I write the claim? Good. H-O or H-A? H-A. What's the H-O? Good. All right, what tail test do we have? Left. This says reject H0. It says fail to reject H0. Okay. In a random sample, here's your sample. 86 adults. He had 20% and a level of significance of 0.05. So what do we do with that 0.05? Inverse norm, we find our critical value. So what's your critical value? Okay, you can round it off. That's your critical value cutoff. Anything to the left of that, reject H0. So do your test statistic. Your p hat minus your p over p times q divided by n. If your p is 0.3, what's your q? 0.7. Everybody realize how to get that? The 1 minus the complement? Like once you do a few of these, do you see the same pattern emerging? Okay, so we're going to plug this in. Your p hat minus your p from your population. Again, that's giving you a negative. So if you notice your tail is on the left, so it kind of falls into place. What happens is sometimes there is a mistake in the wordings, but most of the time, if you find your test statistic is on the opposite side of your tail, something's probably wrong. Maybe you followed the wrong tail. Maybe you put this in backwards. Usually, I would say 95% of the time, it falls where it should. Sometimes it is in the wording that they do something a little bit off, where the numbers push you the other way. But most of the time, you're going to find it stays in the same place. So 0.3 times 0.7 divided by 86. So what'd you get for a z-score? Negative 3.02? 3.2?
No,
2.
2.2. Is that what you
2.2. 2.02.
I got negative 0.665.
I got negative 2.02.
Yeah, I don't know like what I did.
Okay, so put parentheses here.
Do the whole bottom square? Yeah,
You gotta put the whole thing
are on the bottom too.
Well,
You're not supposed
parentheses
to.
around the bottom won't hurt it, but you have to have parentheses around the top.
Yeah, I have it on.
Miss, when you put parentheses, or I mean not parentheses, but the
Square root, entire bottom. Square root over the entire bottom. You actually don't need an extra set of parentheses in the denominator, but you need an extra, need the ones in the numerator.
Why?
Because order of operations will do this. It does a divide first. and then it's going to take that answer and subtract it from 0.20. So you want to force it to do this part, and then divide. The radical will take care of that part of it. It will do everything under the radical first. Order of operations. Did it work now, Taylor? Okay, so is this in the fail to reject or the reject H0? Good. This is in your reject H0. So this is your decision. Okay, now support the claim. The claim was the HA. So we go back to your chart. If we have a claim of HA and we reject the null, that means we've got enough evidence to support your claim that less than 30% of adults in the U.S. are allergic to trees, weeds, flowers, and grasses. Okay. If you put this in your calculator, you have to take 20% of this. So 20% of this is 17.2, right? So you cannot put 17.2 in for your X value. So you have to cut the decimal out. Just use your rounding. Okay, and put your N in there. Yes.
What was that thing? Because I remember we used to have to round up always.
It depends where you're going. Like, I would just use your rounding rules for this one. You can just get away with your rounding rules for this one.
Alright.
Technically, you should round down because you never hit the higher number first. You will never hit that one first, but this one you could use your rounding rules.
What was that whole concept called when we had it around?
Well, because, your sample size, if you didn't hit your minimum sample size, you can't round up because you'd be out of your minimum.
Yeah, exactly. Okay.
Yeah, and sometimes the way the curve goes, you have to stay within a certain area of your curve, so that's why sometimes you round it up, sometimes you round it down. Question? Guys? The p-val? Okay, so we look up your p-val, and we test against your level of significance. So if you wanted to test against your level of significance, we look in your chart for negative 2.02. So look up negative 2.02. 2.02, so that's 0.0217 against your level of significance. So you are less than or equal to, so you are reject H0.
What is 17 now?
17, if you put it in your calculator.
Oh,
That's the X.
oh.
Because what's 20% of this? Am I wrong on 17? Because you have to put in, guys, excuse me. You have to put it in X equals and an N equals. So you need to have your X value. So you take 20% of your sample size, but you have to round. Okay, let's try another one. Alright, I'm not going to do the right-hand one. I want to do an equal one. Okay, here's an equal one. Page 376. The right-hand one works the same as like the left-hand one. Works the same difference, but the two tails work a little bit different. Alright, Harper's Index claims that 23% of people in the U.S. are in favor of outlawing cigarettes. Now, this book is old, you can tell. What do you think that percent is probably now?
84.
Probably like close to the 80s or 90s, right?
Yeah.
Right? I mean, everywhere you go, there's no smoking allowed anymore. So this book is old. And as a matter of fact, do they say? No. So this might be one of their made-up claims. Okay. So therefore, you decide to test this claim. Here's your sample. Here's your N is 200. And you ask if they're in favor of outlawing cigarettes. Again, this is a discrete, a binomial probability type thing. They say yes, they say no. Of the 200 people, 27% are in favor. This is your p-hat. At a level of significance of 0.05, is there enough evidence to reject the claim? Reject the claim tells me, is my claim HO or HA? HO. My claim is HO. So right away I know that. HO, claim. What is my claim? Good. And my HA? So what tail test do I have? A two-tail test. Now, both tails we reject H0. And in the middle, we fail to reject H0. Okay, so now, how am I going to find these guys? One's going to be a negative, one's going to be a positive. Darian.
You do the inverse loan of the significant thing louder.
Yeah?
And
That's 5 by 2.
Good. You have to divide it by 2 because you got to share it between two tails.
that's minus.
Share it between two tails. This is
Genius.
the opposite of your confidence interval. You don't have to subtract it from 1. But you do have to divide it by 2. You have to share it between two tails. So what does this come out to be? Yes.
Negative 1.95.
Okay? 1/6.
I'm sorry, I got around.
Okay? Question, Joey?
Never mind. I got it.
You got it? Okay. Your confidence interval, remember that it's sat opposite. It's sat in the middle. So we always subtracted it from 1. These guys are just the little guys on the ends. So you don't have to subtract anything from 1, but you do have to divide it in 2. The ones we did the last time, I think what confused you guys was when did we multiply it by 2? When we figured out your probability of getting a two-tailed test, we had to take your p-val, your probability area, and multiply it by 2. So that's what some of the confusion with the last time. But when you're taking this, just divide your tails by 2. Again, your formula says same thing. P hat minus P over the square root, P times Q. So your P hat
Divided by N.
is 0.27 minus 0.23. So if this is your P, what's your Q? 77, thank you. So we've got 0.23 times 0.77 divided by 200. Throw this in your calc. I'm sure you have parentheses in your numerator. And you should get your z-score. And your z-score turns out to be 1.34. So where does this fall in terms of our curve? Fail to reject. Somewhere here. So our decision is fail to reject H0. This is your decision. You go back and you look. If you fail to reject the H0, do you agree with the H0 or not? Technically, do you agree or not? If you fail to reject it.
No.
Yeah, you agree with it, right? So follow your chart though.
There's
Your
not enough
claim-
evidence to reject it.
Right, there's not enough evidence to reject the claim that 23% of the people in the United States are in favor of outlawing cigarettes. Okay? Questions on this? Yes. Still having problems with that. Oh, you're taking an extra square root of your 200. Don't take an extra square root of your 200. There, try that. Don't take an extra square root. Okay, try yourself number 2, guys.